Welcome back. This is video 2 of lesson 1.4 for Algebra 2. Remember, we're rewriting formulas and equations, and we're going to focus in on rewriting a linear equation. So, for example 3, we're going to solve 9x minus 4y equals 7 for y. Then we're going to find the value of y when x equals negative 5. Alright, so remember, our first step is to isolate the y. So we're going to solve the equation for y. That's step 1. So as always, we're going to write the original equation. We're going to show what we were given. So we have 9x minus 4y equals 7. Okay, so we're trying to isolate the 4y. So the first thing we're going to do is we're going to move that 9x to the other side with subtraction. So we're going to subtract 9x from both sides. And so that'll leave us with negative 4y on the left-hand side, and it'll give us 7 minus 9x on the right-hand side. So now we're down to y being multiplied by something. Y is being multiplied by negative 4, so we're going to divide both sides by negative 4. So on the left, negative 4y divided by negative 4 is just going to give us y. On the right, 7 divided by negative 4 is going to give us negative 7/4. Negative 9 divided by negative 4 will give us plus positive 9/4. And then we just write that as a coefficient of our x. That's the same thing in case you're wondering, well, what if it was 9x over 4? Yes, having plus 9x over 4 would be equivalent, but the way we tend to write these is that we write the coefficient in front of x. So we write 9/4 x. But 9/4 x is exactly the same thing as 9 times x over 4. Okay, so we've solved for y. So now we want to substitute the given value into the rewritten equation. So we're going to substitute negative 5 for x. So we're going to have y equals negative 7/4 plus 9/4 times negative 5. Okay, so now we're going to multiply. 9 times negative 5 is negative 45, and so plus negative 45 over 4 is the same thing as minus 45/4. So we have negative 7/4 minus 45/4. We're going to combine terms here. We're going to simplify. Negative 7 minus 45 is negative 52. Negative 52 divided by 4 is negative 13. So y equals negative 13. Now, one thing we haven't talked about is checking our solutions. As long as you haven't had to approximate, if you have an exact solution, what you can do is you can plug that value in and make sure you get equivalent statements on both sides of your equation. So you're going to write the original equation, 9x minus 4y equals 7. And then you're going to substitute negative 5 for x, that's what you were given. And then you're going to substitute negative 13 for y, and you're going to make sure you end up with a true statement. So 9 times negative 5 minus 4 times negative 13, we want to know if that equals 7. The solution does check because 9 times negative 5 is negative 45. Negative 4 times negative 13 is plus 52. Negative 45 plus 52 does equal 7. So we get 7 equals 7, and that works. On to example 4. Now this one is going to look very similar at first, but there's one thing that makes it a little trickier, but we can do it. We can totally do it. It's just going to involve one extra step. We're going to rewrite a nonlinear equation. Okay, so and the reason it's nonlinear is because you have an x times y term in it. That's what makes it nonlinear versus the linear one we had, because they look similar, and I want you to know why. And it's because you have x times y. We're going to solve 2y plus xy equals 6 for y. Then we're going to find the value of y when x equals negative 3. Okay, so our solution, we're going to solve the equation for y. Step 1. Alright, so we're isolating y. We start off, we write the original equation, and we've got 2y plus xy equals 6. And we go, okay, we're solving for y. Now, normally what we do is whichever term doesn't have the y in it, we subtract it over. got a problem because we've got 2 times y, and then we have plus x times y equals 6. Both terms have y in it, and that's what we're solving for. So what we're going to do is we're going to undistribute the y. We're going to do the distribute property backwards. Okay, it's still the distributive property. I like to call it. We're going to undistribute it. We're going to pull it out. So we're going to rewrite 2y plus x times y equals 6 as 2 plus x times y. We factored out the y is what we did. We look at those and go, oh, they have a common factor of y. I'm just going to pull that out. So we have 2 plus x times y equals 6. Well, now we're down to just a single term. We've got y, and it's got a coefficient, if you will, of 2 plus x. Okay, it's being multiplied by a number of 2 plus x. It's not technically a coefficient because you've got the x in there, but that's okay. The fact is, y is being multiplied by something. It's being multiplied by 2 plus x. And just like always, when the variable we're solving for is being multiplied by something, we undo it by division. So we're going to divide both sides by 2 plus x. Okay? On the left-hand side, that will cancel out, and we'll be left with y. And on the right-hand side, we'll be left with a little bit of a mess, but it'll work. So on the left, when we did 2 plus x times y, and we divided by 2 plus x, the 2 plus x's canceled. On the right-hand side, we have 6 over 2 plus x, and that's all we can do. Okay, that's as simplified as we can go, and so that is our step 1 solution. We have solved for y. Okay, because it has that plus x on the bottom, we can't really do anything more with it. Step 2, we're going to substitute the given value into the rewritten equation. So we're going to substitute -3 for x. So that's going to give us y equals 6 over 2 plus -3. 2 plus -3 is -1. 6 divided by -1 is -6. All right. And if you wanted to check it, you would just go back to your original equation. You'd plug in -3 for x. You'd plug in -6 for y, and you would double check that it does come out to be 6. So you can check this very much like we did with example 3. Okay, guys, now it's your turn to do the problems to try on your own. Go ahead and do those. Remember, they have to be completed when you get to class. If they're not 100% correct, that's okay. You just need to make a good effort at it. Remember, we will go over those kind of as a warm-up before you get started on your rounds.